Okay guys, so today we're doing solving absolute value inequalities notes. Last time we did equations, now we're just going to add inequalities to it. So less than, greater than, or equal to, all that stuff. These notes look very similar to the last one. Okay, almost identical. And that's because it's almost the same process. So we're going to use basically the same examples to show how this is going to work. Alright, so first, again, I want to show you visually what this is going to look like. I'm going to color code these two. We want to solve absolute value of x is less than 3. So we're going to graph both of those things. This is the graph of y equals 3. This is the graph of the absolute value of x. Okay, as you can see, we intersect there and there. And we want when absolute value of x is less than 3. So we can look at our graph visually. It's greater than 3 up here. And then when it crosses here, it's going to be less than 3 for this whole time. And then it goes back above 3. Okay, so we can tell from our graph that this little area here is when absolute value of x is less than 3. And we have open dots because we're strictly less than. Okay, that's what it's going to look like. That's our solution. So to go back and reiterate, the absolute value of x means the distance x is from 0. Alright, so looking at this little line chart over here, we want the distance from 0 to be less than or equal to, or less than, strictly less than 3. So we can be at 1, we can be at 2, we can be pretty much anywhere between -3 and +3, because outside of that we're going to be more distance from 0 than 3 units. So it's going to look like this. We got our open dots, and then we can shade in the middle. That's the idea. So looking at this graph, we can tell absolute value of x is less than a means x is less than a, or x is greater than -a. And really this should say and. Okay, because it has to be less than a and greater than -a. So in this case it's less than 3 and greater than -3. It's everywhere in between. Alright, another way we can write that is -a is less than x is less than a. So x is between -a and +a. A is just some number. We don't know what it is. Alright, but that's what it looks like. Okay? So to solve our equations, it's going to look really similar. Again, you don't have to do all this graphing stuff. What we're going to do is we're going to split into two equations. But we're going to split them a little differently. So the first one's going to look just normal. X is less than or equal to 4. Our second one, again, we have x, and we're actually going to flip the sign on -4, or 4 again to get -4, but we also have to flip this sign. Okay, that's the difference here. Alright, we have to change our less than or equal to greater than or equal to. So we split into two equations. We have x is less than or equal to 4, and x is greater than or equal to -4. So our graph is going to look like this. 0, -4, +4. We have less than or equal to, so we know we're going to have closed dots. Okay, and then we're everywhere in between there. X is less than or equal to 4, and x is greater than or equal to -4. Okay, so we're right in between there. Solving, again, is really similar. Okay, we are going to have to graph most of these, so we can't just write an answer like we used to be able to, but the process is not much harder, as you'll see. Alright, let's try another one. Again, solve for x. We have the absolute value of x plus 2 is greater than 5. We have our absolute value all alone on this side. So we can split that into two equations. We get x plus 2 is greater than 5, or x plus 2 is less than -5. Again, we flip that sign and we flip that sign. And we get x is greater than 3 and x is less than -7. Okay? So in this case, we're going to see something a little different. Up here we had x is less than a, or absolute value of x is less than a. And so we had x is between -a and +a. Now in this case, we're starting with this absolute value being greater than a number. So we want the distance to be more than 5 away. So I'm going to graph -7 and 3 on here, okay, because we're greater than 3 and less than -7. but our graph's going to look a little different. We got open dots, but we're greater than 3, so we're going outwards. And we're less than -7, so again we're going outwards. Now we have two separate parts to our solution set. Okay, and that's because now we want our distance to be greater than 5 rather than less than something. Okay, that's the difference there. That's why our graphs look different. Alright, and you'll get a handout that's going to help you guys with that. Alright, let's go on to the back. Okay, again, note we can only split our equation into two pieces when our absolute value is alone on one side. I keep reiterating this because it is vital. You cannot split your equation until you get your absolute value alone. So in this first example, we're going to have to move this to the other side. We get absolute value of x is greater than or equal to 9. Okay, now we can split it. We get x is greater than or equal to 9, or x is less than or equal to -9. And our graph is going to look like this. -9 to 9. Okay, so we want our distance to be greater than something, so we know we're going to go outwards. We have closed dots. Shoot, let me change color. We have closed dots. Okay, and we want to be greater than or equal to 9. So going outwards, or less than or equal to -9. So again, going outwards. Alright, simple enough. Moving on. Okay, so now again, we don't have our absolute value isolated. Let's go ahead and divide both sides by 2. We get absolute value of x plus 3 is less than or equal to 3. Okay, now we can split it. Our absolute value is alone. So we get x plus 3 is less than or equal to 3, or x plus 3 is greater than or equal to -3. So x is less than or equal to 0, and x is greater than or equal to -6. Alright, so we had our distance less than this time, so we know when we graph we are going to be going inwards. We're going to have x's between -6 and 0. We have closed dots. And we're less than 0 and greater than -6. So we're right in the middle there. Okay, looking good. We got one more example. Okay, so this one is pretty ugly. We seem to have trouble with these. I think what a lot of people are doing are either splitting it up immediately, which you can't do, or ignoring these absolute values, which you also can't do, or distributing this 3 into the absolute value, which you can't do. Okay, we got to take care of this 4 and then this 3, and then we can split. That's the only way to handle this. So let's go ahead and add 4 to both sides. We get 3 times the absolute value of x minus 1 is less than 12. Ignore this little mess here. Sorry about that. I copied that down wrong. Okay, so we have this now. Now we got to divide by 3 both sides. We get x minus 1 absolute value is less than 4. Okay, and then we can split. We get x minus 1 is less than 4, or x minus 1 is greater than -4. So x is less than 3, or x is greater than -3. I'm sorry, x is less than 5. My bad. Alright, now we can graph. We can put -3 on there and 5 on there. Our distance is less than, okay, so we know we're going to be in between. Alright, we're less than 5, greater than -3. So we're in between there. Okay, pretty simple, not too tough. I do, again, want to bring something up at the end here. Yeah, let me put it over here. Alright, I'm going to take this question, and I'm going to rewrite it over here a little differently. I'm going to make this 2 negative. So I don't know if you guys recall when you first learned inequalities. When we solve and we're dividing or multiplying by a negative number, we need to flip the sign. So in this case, this -2, we're going to get rid of that by dividing by -2. Okay, so we're going to have absolute value of x plus 3 on this side, and we're going to have negative 3 on this side. Okay, but this sign is going to have to switch. We're going to have to be greater than or equal to, because we divided by a negative number here. If we divide or multiply by a negative number, we're going to flip the sign. For a similar reason that we flipped the sign over here. Okay, for the same reason. Okay, now we can split it up. We're going to get x plus 3 is greater than or equal to negative 3, and x plus 3 is less than or equal to 3. So x is greater than or equal to negative 6, and x is less than or equal to 0. Okay, so there you go. I'm not going to waste my time graphing that. That's it, guys. Okay, this is pretty much all we're going to have to do with absolute values. Okay, I think we pretty much killed it. Everybody's grabbing or getting a good hang of it, so appreciate it. Cool. Have a good one, guys.